going to talk about discrete event simulation, how that works, mostly as it pertains to ExtendSim, but a lot of this is true for any simulation software program. If something's not clear or you have any questions, feel free to interrupt me, and I'll do my best to explain it, or Robin will help as well. So event is one of the big words in discrete event simulation. And what that means from Banks, Carson, Nelson, Nickel, which is a popular simulation textbook, is an event is an instantaneous change that may change the state of the system. And in a simulation model, events really drive the simulation forward. The simulation clock jumps from one event to the next, and nothing happens in between events. So what we're doing in a discrete event simulation is we're scheduling something to happen at some future point in time, and then we're moving the clock forward to that point in time. And we're always looking at the earliest event to happen in the future. So we're just moving from one event to the next. So the movement of the clock is not linear. It's kind of lumpy depending upon the time between the events. And we'll look at some examples of this. So there are two types of events. There's a future event and a current event, or a ZeroTime event. So I refer to it either way as a ZeroTime event or a current event. Now, future events occur at some time in the future, usually, but not always. And it's really by far the most common case that we're going to have a future event that is some positive amount of time in the future, something greater than zero. So it might be an hour in the future, might be a minute in the future. So, for example, when an activity starts, it's going to schedule a future event of when that activity is due to complete. So that's usually going to be sometime greater than zero. But there's nothing saying you can't have an activity that has a zero duration. In some cases, that can be useful in a model. That's still a future event. It just happens to occur at the same time as the current time. Now, a current event is something different. Current event is very specific. It always occurs before the clock advances. So this is a zero-time event. So the simulation clock will not advance if there are pending current events. So it processes the future events, and it looks at the current events, and it processes all the current events. And generally, there's going to be many future events out there and one or more current events at each step. Current events are quite common in ExtendSim. The future events, there are three components. There's the time of the event, when will that event occur, the block that has that event. So you have to have a block to have a future event. And the message time. So what is this event for? So when is the message? Who gets the message? And what is the message for? So in our activity example, we would have the time that the item is due to complete in the activity. The block would be a particular activity block number. And the message would be the completion of the duration of an item in the activity. Now, some blocks have one event, and some blocks can have multiple events. How are future events stored? Well, if you're going to plan something in the future, where do you store it? Well, how about a calendar? Simulation programs, discrete event simulation programs, have an event calendar. And that stores the event time, the block number, and the message time. So that should sound familiar. So if we go back a couple slides here, what they're storing is the time, the block number, and the message time. So I've got a simple example here. In brackets, these are the block numbers. So there. These are all the block numbers. And in ExtendSim, each block has its own unique block number. So it's the easiest way to refer to a block. The event calendar looks something like this. This is kind of a stylized version. We have the event time in one column, the block number that event time refers to, and then what type of message is going to that block. So at time 2, the activity block number 5 is going to get a message. And that message is going to say an item is complete. Now, the executive is storing the event calendar, and it doesn't actually know what the message type means to the block. but the block has told the executive that at time 2, I'm block number 5, and I want to get an item complete message. So like any good executive, it really doesn't know much about what's going on. At time 2.5, activity number, or the create block, is going to get a message to create an item. At time 3, another activity number 10 will get a message to that item is complete. And at time 240, our shift block is going to get a shift change message. Now, in general, what's going to happen here is that there is going to be other messages that occur between the current time, which is sometime before time 2, and 240, which is the shift change message. So these event times will change dynamically. But the block numbers and the message types, they don't change. They stay the same throughout the simulation. The event times will change as the simulation moves forward. So we might see that another item moves into activity number 5, and its event time might advance to, say, for example, time 5. So what blocks use future events? Well, the activity does, and we talked about that. The create block, the convey item block, and the convey item block actually has 2 different kinds of events. One is when it can bring an item on the conveyor, and one is when an item can leave the conveyor. So it actually has 2 different event slots in the event calendar. Transport block, of course, which is much like an activity. The shift block is scheduling when the shifts change. The shutdown schedules when a failure occurs and when the repair completes. The pulse block, which is in the value library, and it sends out a pulse every so often, and that time between pulses, every time there's a pulse, it schedules the event time for the next pulse. The lookup table, if you have the time-based lookup table block, it will schedule an event at each time that the value changes. Note there's a commonality here that these are all blocks. So you have to have a block, as I said earlier, you have to have a block to schedule an event. And the queue also schedules events. And there are actually 2 different reasons why a queue would schedule events. And I've got a little poll for this, if you can bring that up, Robin. And let's do a test. Let's see if you guys do better than the morning group did. So if you guys don't mind filling out the poll, we'll get an estimate of a little test here. So let's look at the results. Well, that's about the same as this morning, isn't it? Robin?
Yeah, pretty close. Pretty close.
Okay. Yeah, most people had that scheduling the minimum wait time was indeed one of the uses for it. The other one is reneging, because when an item arrives, it will have the reneging is kind of an expiration date on the item. It'll go in there and it'll wait for a while, and if it hits that time, hits its expiration time, then it will leave through the renege connector. So it schedules an event to know when that item can leave. So we don't need it for the resources, because the resource manager or the resource pool blocks, they actually deal with the resources. And animating the contents, that's just done as items come and go. And then the shift-based waiting time is actually done by the shift block. So the shift block is scheduling events, not the queue block in that case. So that's a little bit of that was a little trickier one there. It looks like we did pretty well on that. And then one of the most interesting places where you can schedule your own events is the equation block, where you can actually create your own event time. So you can put in your equation the time in the future when you want the equation to evaluate. And there's another option which is quite useful as well, is that you can tell the equation to be delayed by a 0 time for a current event. So the equation gets a signal to evaluate, but you can say, oh, no, don't evaluate me immediately. Return from whatever told me to calculate, but give me a 0 time event so that before the clock advances, I want to do a calculation. And this can be very handy where you want to control the sequence of events in the simulation. We'll actually look at examples of both of these. What happens if we have more than one item in a block? Is there one entry per item in the event calendar, or does each block that has more than one item in it have its own event calendar? So we've got another poll about this. Let's see how well you guys do at this one.
So what's the question again, Dave?
If there are multiple items in a block, how do we deal with that? So we've got an activity with capacity of, say, 10. And I've got 10 items in there. In that activity, does that have 10 slots on the overall event calendar? Or does the activity have its own event calendar inside the block and just have one entry in the overall event calendar. And it looks like we got about half of us got it right. So one of those answers is right. Actually, each block that can store multiple items has its own event calendar. And that works out to be more efficient because that means that we could have an activity that has 1,000 items in it. And it has its own event calendar that changes dynamically in size with the number of items inside of the block. But the overall executive event calendar is constant in size. It never changes because the number of blocks in the model don't change. Also, it's efficient because a block may have different needs for its own event calendar. For example, the minimum wait time in a queue, we actually use a very simple structure for its event calendar. And I won't go into why, but it's a very simple thing we can do so that it's an efficient, small event calendar. The activity has a more complicated event calendar because it's a more complicated block. So we can have different kinds of event calendars in different blocks. So it's a very efficient way to model that. So I'm going to show a demonstration of that. Here we have a very simple model. We've got two activities. So these are activities here and here, and two queues, and a create and an exit. So this is a pretty standard, straightforward model. These activities are actually hierarchical blocks where I've gone in and done some additional animations so we can see a little more of what's going on. But we'll see as the items enter the activity, we'll see a number inside of the activity. Let me just move forward to that. There we go. And that is this value in here. This is the activity's time in the event calendar. So the next event to occur for that activity is at 1.42. But internally, it has one item whose duration or will be leaving the activity at time 1.42. So these values are the same at this point because there's only one item in the activity. So we can see that an item arrives and it's scheduled to leave at time 1.42. So let's move forward a little bit. And we'll see some more items enter the activity, and we'll see some more times show up there. But you'll notice that it always takes the shortest of the time. So one item is leaving. So it's the activity's time is delayed to 1.61. Now we can see we've got two items in the second activity, and it's taking the smaller of the two items. So it's got an item at time that's going to leave at time 5, and an item that's going to leave at time 10.51. I'll go through it a couple times so you can see what's happening.
So, Dave, just to make sure I have this clear, the time that's inside the activity block, that's the one that the executive is concerned with, and the only one for that block. But
right.
Inside the activity block, it is concerned with all of it manages that list above it itself, correct?
Yes, absolutely. So the activity has this list. All the stuff above the activity is the list of items that it's keeping track of. But it's only posting one value to the executive. Now, it could post more than one value to the executive, but the number of values that it's posting for the executive is fixed at the start of the simulation. It can't change it during the simulation. So because the number of the items in the activity is dynamic and it can change by a wide amount, we have one kind of event calendar in the activity and a different kind of event calendar in the executive. They're both doing the same thing, which is keeping track of all the things that are going to happen in the future. But the data structures are a little different between the two of them. Any questions about that? Okay. So let's just play that again. We can just watch it happen one more time to give everybody a good idea of what's going on in the simulation, because this is an important part of how ExtendSim works. Any questions on that? I'll move on. It's kind of an interesting model to me to kind of see how all this works. It's a little bit unrealistic in that we're seeing the items kind of go into specific slots, and I made it work that way so that you could kind of get a sense of continuity, but actually the activity, that list of times is sorted within the activity. So it would probably actually show the values. Another way to represent this would be to show the values small to large above the activity, because it's actually sorting them as it puts them into the event, its own event calendar. All right, let's go back to the presentation here. So that's kind of that's the brief overview of future events. Now, current event is kind of a hold that thought. It says, okay, somebody told me to do something, but I don't want to do it right away. I want to return and let whatever is going on happen. And then, but hold that thought. Get back to me before you want the clock to advance. So it allows a block to return from a message immediately while getting another wake-up message before the clock advances. And when you get in the mechanics of simulation, it's important to be able to do this because you may have a message that's caused by seeing an item moving, and that may cause another item to move, and that may cause another item to move. And all of a sudden, we've got a simulation engine that has to deal with any number of items trying to move simultaneously. And you get into deadlock conditions and all sorts of nasty stuff that happen when you're trying to do all these things at once. And it tends to work out much better if you say, okay, I want one item to move, and I'm going to let it complete moving, and then I'm going to move the other item, and I'll let it complete moving, and then I'm going to move another item, and let it complete moving. So when you do these things kind of sequentially, it makes things much cleaner and work in a more orderly fashion. So let me give you an example of that. I've got just an activity, and a wants message is going to come in on the output connector. That says we're going to try to pull the item out of the activity. So in response to that, the activity is going to post itself on the current event list in the executive. So it's going to tell the executive, get back to me before the clock advances. Before you move to the next event, get back to me. So the item is going to continue to a downstream block, and then the activity receives a message. It's zero-time event, so it can try to pull in another item. Because if it tried to pull in another item in response to the wants message, I'd have two items moving at the same time. And that gets very complicated to deal with from a software standpoint. And it makes it hard to understand what's going on in the simulation model, because the item that started the pull message will kind of be suspended while another item moves into the activity. So let's watch an animation. So I get the wants message on the output of the activity. The activity sends a message off to the executive saying, wake me up before the clock advances. The activity sends the item out, and it kind of disappears. The activity is no longer concerned with that item. It gets the message back from the executive saying, okay, you wanted me to ping you before the clock advanced. I'm sending you that message. And now it's going to bring in another item. Let's watch that again, just because I spent a lot of time doing this animation. So I get the wants message. Activity sends the message saying I need a zero-time event to the executive. The item leaves the activity. The executive sends the message back to the activity so that it can bring in another item. Are there any questions on that? So this is an important mechanism that we use a lot. And the zero-time or current events are handy, and they're also efficient. So if you're programming a block, don't be afraid to use them. They have very little overhead, and they can be very useful in avoiding situations where you've got a lot of things on the stack or a lot of pending operations at once. It allows you to kind of clean up all the pending operations and then come back and revisit your own block of interest at some point later. So let's look at some applications. I've built a small model here, and this is just I've got 3 machines in series. They're all identical, and we can see a hierarchical block of what's inside of there. I've got a queue with a limited capacity. So if you notice, our queue has this little lid on it. That says, whenever you see that, that says that the queue has a limited capacity. I've got a shutdown block here, so my machine is going to fail every so often. And I'm looking at a couple statistics in this case, which is busy, blocked, and down, and I've got them kind of compressed, but they're all going off to an equation block over here so that we're processing those. Now, what I wanted to do here was update our busy, blocked, and down statistics. You see over here, and up here, and up here. I don't want them to update whenever they change. And this is the default case in ExtendSim. They're just going to, whenever value changes, and we've got it animated, they're going to update automatically. I wanted to just update those every so often so that it looks a little better in the animation. And you'll see how nice this animation looks. So I've got an activity here, or an equation block that's set to calculate it 2 times, and these are these 2 little buttons. Let me clear out my these 2 little dots here. This says we're going to evaluate it at once at the beginning of the simulation and then in response to events only. So we're going to only calculate once at the beginning of the simulation, and then the equation block is going to schedule an event that's going to perform our animation. So let's see what that looks like. I'm going to start with the equation tab, the options tab on the equation, and I've got an option here that says use the calc event time output variable. So this adds another output variable which we can set, which says this is the time in the future when I will calculate that equation. So I can tell the executive to record a future event for this equation block based on the value of this variable. Then I've also said that the equation is going to calculate at the start of the simulation. And I want it to do this so that I can set our first equation calculation. This is our equation here. So I see if the animation is on, then I have, I'm animating the 3 values that are coming in busy, blocked, and down. So this animation text transparent that just sends the value off to be animated. The -1, -2, -3 says I'm animating on the hierarchical block, not on the equation block itself. And then my event time is going to be whatever our current time is, plus 6 minus animation get speed. Animation get speed is 1 to 5, and that's the speed of the animation. So the faster I animate, the closer together I will be showing these values. So it gives me the ability to kind of dynamically control how often these are there. So I'm dynamically changing my event time based on the speed of the animation, which is kind of a cool thing to do when you think about it. And it gives you an idea of how flexible this block is and the event scheduling is within the equation block. And this is where we're setting our event time value. So you can see that we've got an output variable, which is the event time, and the time at which it's going to be calculated. Let's take a look at this. Let me run it back to the beginning here. So what you'll see are that these animated values, which show busy, down, and blocked right here, here, and here, they'll all update at once, and they will update at specific time intervals. So they won't be updating every time they change, but they'll update every few time units. And I know that's a little hard for you guys to see, but you'll have to take my word for it that that's the way it's working. If anyone's interested, I can send off this model that works. So that's a neat way. Actually, Robin suggested this as a way to utilize the event scheduling in the equation. Let's watch that again. And we can see those values just changing at specific event times all at once. model I put together here is a model that illustrates jockeying. So if you're familiar with the jockey model in the examples folder, what happens is there are 3 waiting lines. And like a supermarket, if you go into one waiting line and you look over and you say, well, wait a minute, nobody's in the other waiting line, and I've got 4 or 5 people in front of me, I'm going to back up and move over to the shorter line. So you evaluate that whenever somebody leaves, you're always looking around to see whatever, at least I am, looking around to see whatever line is the shortest. So let's take a quick look at the model and we'll see how that works. Okay, so we've got customers arriving over here, and they go into one of these 3 service lines, checkout lines, over on the left. And so these are our checkout lines here, right there. And we've got an equation that's looking at the length of the line for each one of those and saying, well, if it's a lot shorter than your line is, then you'll want a jockey. So they send the jockey signal out, which is the jockey 1, which is right there, and then jockey 2, and then jockey 3, each line. So it's dynamically deciding, well, one line is a lot shorter than the other 2, so we're going to tell someone to go back and move into the shorter line. And I'm not going to get into the logic of that. One thing we've done here, though, and this was the behavior in version 7 and earlier, we only had the choice to respond immediately. So when we get that signal saying, oh, the line has gotten shorter, then we make that jockey event occur immediately. Well, what happens in practice is the line gets shorter as soon as the item starts to leave. As soon as the person starts to leave, then that line gets shorter, and then the jockey event occurs. So we'll see what happens is that person disappears, and then the jockey event occurs, and then that person that's going to leave reappears and leaves the model at that point. So this is what I was talking about, where we've got one event that's causing another event to occur, and it kind of suspends the first event so that the second event can occur. And what we might want to do is make it so that the second event doesn't occur until the first event is completed. That makes the model appear to flow much more smoothly. Now, both of these models that I'm going to show you actually get the same result. It doesn't matter how we do it from a statistics standpoint. But if you're trying to demonstrate this to someone, it can be a little disconcerting to see people just kind of disappear and then reappear later. So let's watch what happens in the model. So we'll see someone arrive. Okay, and then someone is completing, so they're going to jockey. So we'll see them disappear. Now we see the jockey events. And now the guy that was leaving reappears. And we'll see the same thing occurs again up at the top part of the model. So we're going to change the equation to calculate after a zero time or a current event. Now let's back up just a hair here. Okay, down here, what I've changed is this option here. So we're going to respond after a zero-time event. So the equation is going to get a message, a notification that the length has changed, but it's going to say, oh, okay, I know something's changed. I know I've got to calculate, but I'm not going to calculate right away. I'm going to return from that message, and then the executive is going to tell me before the time is advanced that I'm going to recalculate again. So let's watch what happens in this case. We'll watch this a couple times. So the customer leaves. Watch this. You can actually see the customer leave, and then we see the jockey event occur. So if you had to demonstrate this model with someone, this is a lot easier to talk about than that kind of disjoint behavior where we've got this sequence of events that's causing something that looks a little odd. So let's look at that whole thing again.
So, Dave, just to clarify things, so this option at the bottom is not telling the equation to be an event posting block. It's just saying to reschedule itself now, correct?
Right, right. It's not on the event calendar. It just has a zero-time event. So zero-time events don't go on the event calendar. They're just a message sent to the executive that says, get back to me before you send an event. And that's part of the reason why they're so efficient, is because we don't have to keep them on the event calendar. Anytime you put something on the event calendar, there's some overhead to it. But the current events or zero-time events don't go through the event calendar. Essentially, they're short-circuiting that. And that's part of the reason why they're there, is because they're more efficient.
Whereas on the other equation example, with the output variable type being a current event time, that did make it be placed on the event calendar.
Yeah, that's a really good distinction. I'm glad you brought that up, Robin. Absolutely. Are there any questions about this? Okay, let me move on to one more example I have. I didn't record this, so you'll have to look at the ExtendSim model. Open it up here. In this case, and don't worry about this, I was demonstrating someone how they could combine blocks together to perform calculations. What's important about this model, what's interesting about this model is over here. And this is, what he wanted to do was have an hourly report of the service level and of the utilization of agents in a call center. So we have an equation block that's set to calculate. We've got our event time variable right here, and it's set to calculate every hour. So our event time is current time plus 1. The way this works, it actually gets called twice at every event, once to calculate it, and then once to clear the statistics. So I've got this variable here that checks to see if the statistics are cleared, and it just toggles back and forth. I'm not going to get into all that detail. But I wanted to show another example of how we can use the event scheduling. In this case, we send out a message to a write block, and that write block is writing out at hourly increments, these are hours, the utilization and the service level. And then it's also clearing statistics so that we're getting the utilization and the service level just for that interval, not for the simulation so far. Okay, and then we're clearing the statistics down here. So just giving you an idea of all the things. It's another example of something you can do by scheduling an event in an equation block. Now, there are other ways we can do this, but one way, for example, would be to create an item every hour. But there's a fair amount of overhead to creating an item. We have to allocate memory to that, keep track of it along with all the other items in the model. So this is a more efficient, cleaner way of doing the same thing. And in fact, I could do the whole thing in one block. I chose to do it by having the write block and the clear statistics block. I could also do it just in the equation block. I could have it write the data and clear the statistics all from the equation block alone. So equation blocks are actually quite powerful in this sense. Okay. And we'll make these slides available. The slides actually have embedded videos, but I'm having to jump to the video player because for some reason they don't play through the GoToWebinar software. But if you want to download the presentation, you'll have that right embedded inside of it, so you don't have to go. So other uses, I talked about this, is to generate a report or log records at specific intervals. You can check for conditions at a specific point in time. So you might want to say, well, at noon, I want to see what's in the queue so I can decide whether or not to add more servers at that point. Another one is control logic, and that's we can check to see if a condition is true after a time delay. So if someone's familiar with working with PLC controllers, this is a good way to simulate their behavior. We use that in there's a green veneer, Southern Pine green veneer, I forget the name of the models. It's a veneer production model. And that actually has a control logic in there that looks to see if a conveyor has a certain number after a certain amount of time has delayed on that conveyor. So it's a powerful tool for that sort of thing as well. Also, you might need to control the sequence of item movements. And this is much like what we did in the jockey model, where we might say that ExtendSim by default is going to make things happen in a certain order with the equation block and being able to delay something either by a future event or a current event. You can have more control over the sequence of the movement. That's all I had. Robin and I are available for other questions. Appreciate you guys taking the time to listen to me talk. If you have any other questions or anything like that, Robin and I will hang around for a bit. Otherwise, we'll sign off shortly.